All right. So we've gone from an observation to a hypothesis. Now, the thing about a hypothesis is a hypothesis involved making predictions about what's going to happen. I think that there's algae growing in the water because there's so much sunlight and because there's so much sunlight. So if I put the algae in a dark place, put the water in a dark place, the algae will all die and settle to the bottom. That prediction can then be tested. You see, the scientists will think of a Y, the hypothesis, and then test it to see if that Y holds up under observation. Now, to do that test is an experiment. An experiment is an attempt to prove or disprove the hypothesis you've come up with. Now, the key thing about this is to understand, like we've already talked about, mistakes, error, not just trial and error. The error is a part of it. When your hypothesis is incorrect, you don't feel bad about it. It's not like you come up with a hypothesis and, oh no, it has to be the right guess. And if it's wrong, oh no, I've done terribly. No, it's not about guessing right or wrong. When you test the hypothesis with an experiment, you receive data. That data then allows you to refine the hypothesis so that it is more likely to be correct, so you can run a different experiment that seeks to prove or to show whether or not your new hypothesis is accurate. So remember, you start out with the observation, you make an inference from that observation, you do a little research to turn that inference into a hypothesis as to why it is happening, and then you run an experiment. Now, in running an experiment, this is a great little example of how that works.
Psychology in the Fast Lane. Difficult topics explained. Experimental design. Think of the experimental method as a way of isolating what is causing something to happen. Here's a simple example of isolating a cause. You notice that your car is making a squeaking noise when it's running. You walk around the car and listen for where your sound is coming from. You notice that one of the parts is wiggling around. By listening to locate the source of the sound, you used your auditory perception, and you've confirmed it with visual perception. So you hold it in place and the squeaking stops. You let it go and the squeaking continues. After repeating this action, you can conclude that the wiggling part is the cause of the sound. Tighten up that part and you now have a quiet car. First you observed the squeaking sound, then you described it by pinpointing its location. Then you made a prediction, or you hypothesized that the wiggling part may be related to the squeaking sound. Then you tested your hypothesis by stopping the wiggling part and observing the sound stop. You repeated the test and compared the non-wiggling and wiggling conditions, or the control and experimental conditions. Then you came to a conclusion. The wiggling of the part is causing the squeaking noise. And you acted, tightening the mechanism to keep it from wiggling, and you fixed the problem. Science at its most basic. Now, let's look at an
All right, so science at its most basic. You perform an experiment to test your hypothesis. Now, where we would talk about doing research to better understand an inference, that video talks about walking around the car. See, the research in that situation is walking around the car to figure out where the rattling noise, where the squeaking noise is coming from. It's the same principle done a little bit differently.